I don't know what happened. Okay, so real quick, let me just reread the problem for the internet people. Two gears are adjusted so that the smaller gear with a radius of 3.6 inches drives the larger one with a radius of 5.4 inches. If the smaller gear rotates through 150 degrees, through how many degrees would the larger one rotate? So I have two gears here. I'm going to have the larger gear with a radius of, what did it say? 3.6. I have a larger gear with a radius of 5.4. So they are going to be, the cogs are going to be intertwined. So as this smaller one rotates, it's going to force the bigger one to rotate, right? We follow this?
This is actually really
Yeah, this is really good. So what's going to happen is your smaller one, we're going to rotate it through 150 degrees. So let's assume this right here is my 0 mark. So if I turn it to 150, I don't know, about to here. So I know the little one's going to turn 150 degrees, but how much will that make? Actually, let's start it off maybe like here. This is obviously not precise, but anyway, if I turn that one through 150 degrees, how far did the big one go? So it's clearly something less than 150. You follow me? So that's what I'm trying to figure out. How many degrees did this big one spin? Okay, well, there's our visual, but how in the world are we going to do that? Oh, that's an idea. So Andrew says if we figure out the length of this, the length of the arc that it actually turned this, wouldn't, so when the small gear turns, as the small gear turns, the length of the arc would be the same on each one that gets, right? So whatever this length is, that's the same length that it turned this one.
Isn't it like proportional though? Because couldn't you say like if you find the arc of the smaller gear, whatever that number is, over 3.6 equals x over 5.4? Good, right?
I don't think that would help you solve this though.
Oh.
I don't think so. Yeah, so this, we need to figure out S for the little gear. That's how, yeah, and then we'll move on to the big one. So, S for the little gear. S equals R theta. I don't know what S is. I do know the radius of the little gear. It's 3.6. And I do know that the little gear went through 150 degrees, so I need to put that into radians. So 150 degrees times pi over 180. So now I'll figure out the length of the edge of the circle that the small gear turned.
Yeah, 2.6.
I had an error in there. I hit a wrong button. 3.6, 150, pi over 180. Okay. What'd you get?
I got 2.6.
I got 9 points.
Yeah, I'm in 9 something.
Did I do something? Oh, wait.
Yeah, check your.
I didn't multiply it by 3.6.
Oh.
There we go, 9.4.
Okay, and what are my sig figs going to be? 2. So this number would be 9.4. So here's what's so cool. Now when I go over to the big gear and I do S equals R theta, I do know what S is. It went through 9.4 inches. I know S this time. I know the radius of the big one is 5.4. Remember, I'm trying to find how many degrees it turned. So I'll be able to solve for theta, but will that be my answer?
Oh,
Why not?
yes.
Ah, you gotta find the
It's going to be the same.
Oh, then my little proportion thing doesn't work.
When we solve for well, let's solve for theta right now, right? Wouldn't I just divide both sides by 5.4? Right, you guys with me? So I'd have 9.4 divided by 5.4. That tells me that theta
1.7.
is 1.7. Is that my answer?
No, you probably gotta plug in some back end.
That's the degree of the radian.
You tell me. What is
Well, I
that?
asked you.
Well, in this formula, guys, what is theta always in?
Degrees when you normally start and then you have to convert it.
You always have to put it in radians. So right now, it's in radians. I don't want radians, though. I want degrees. By the way, think about it. 1.7 degrees,
Yeah.
that's so tiny. So it's not really a reasonable answer. So this is radians. So I have 1.7 radians. How do I change radians back into degrees? 180 over pi.
Given a big number. 97.4. Oh wait, no, it just be 97.
1.7 times 180 divided by pi. Yeah, 97. So it's going to move approximately 97 degrees. Does that make sense? And, I mean, these are totally not to scale. I didn't measure them. I don't know that that's clearly not 3.6 and 5.4. But just to give you a rough idea, right, when we did it, so look at where 5.4 is starting. So it's pretend this is our 0 point, right, 3.6. So as I turn it, 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 turn it. I mean, look at where I'm at. I'm not that far off from 97, am I? Right, from where it started here. Again, not to scale, but I have a rough idea. So 97 is a totally reasonable answer. Pretty cool, huh? These are some great gears. Okay, last little bit. Do you remember in geometry finding area of a sector of a circle?
Yes.
You do? Wow.
No,
Can you tell me what a sector of a circle is?
a quadrant.
It's like a pizza slice.
Yes! Oh my gosh! You're totally right. So,
Quadrant pizza size?
Quadrant is a big.
We're talking
Well,
about
quadrant-
multiple quadrants.
quadrant would specifically be a fourth, though. This doesn't have to be a fourth.
Oh, quad, yeah.
Yeah.
If your piece of pizza is a fourth of
Six-
Then I guess you could talk about it that way.
a slice of pizza, right?
So, all right, guys. Take a look here. I'll just draw you sector of a circle. So you have a circle,
I always have to cut them in four.
right? Guys, you follow? So if I have a radius of that circle, and then I have some other radius, okay, wherever it is, that region in between the two radii, Andrew, are you listening? Is everybody listening? That region we refer to as a sector of a circle.
That point is supposed to be the.
That's the center of the circle. Yeah.
Do you like brick oven pizza? Your pizza looks black.
That's the place back on.
Yeah.
Hello, Mr.
Hi.
Hey, how are you?
Good. How are you?
Byron? Can I talk to you?
Sure. Okay, so that's what we're talking about when we refer to a sector of a circle. When we taught you how to find the area of this in geometry, when you didn't know about radians, we had this very complicated way where you did the whatever degrees this was over 360 to get the fraction of the circle that you're talking about times the area of the whole circle. Now, since we have radians, our formula is a little bit easier. So to find the area of a sector of a circle, just like this one, I'm just going to do 1/2 the radius squared times theta.
By central angle.
So a central angle is any angle whose vertex is on the center of the circle.
So that's the one going. Wait. What? What's 180 degrees?
180 would be if I cut a circle in half and it's,
108.
oh, 108?
The central angle of 108.
Oh, okay, I'll draw that. This wasn't meant to go with that problem. I was just showing you what a sector was. Sorry. Yeah, I just wanted to refresh your memory what a sector of a circle even was. Okay, now let's look at example 5, okay? So example 5 says, find the area of a sector of a circle having a radius of 15.20 feet and a central angle of 108. So if you're going to draw this out, you have a radius 15.20 and then central angle of 108. So that would just be about there, so where this is 108 degrees. Oh, sorry, let me make this a little darker.
1/2 15.2 squared times 0.85/1.
That's it. So right now, when you use this formula, A equals 1/2 r squared theta, as long as you put theta in radians, you're going to find the area of this entire slice. Okay, so if this were pizza, it would be the area of pizza that you, but that's hard because pizza really has volume. It's not paper thin. Hopefully you got some.
Some people like that.
I like thin crust, yeah, but it's not, anyway. 1/2 radius 15.2. So, what is theta? Can I just put in 108?
No.
No, you gotta change it to radians. So 108 times pi over 180. And then it's just a math problem. Problem for our calculator.
Well, 217.
17.75.
What? Oh, I forgot to square it. Oh my gosh. Silly goose.
Well, I guess in the summertime.
Is that what you guys got?
Yeah.
And how many sig figures are we gonna go out?
No, yes, 3. From the 108. Oh, it has a point, damn it. Crap. 4.
4. So,
217.8.
correct. So the area of this 217.8, and my units would be, what are,
Feet.
feet squared. Remember, any units for area are squared. Alright, and that's pretty much it. Okay? Yes, today was very good. But notice that it's really just, most of it was just this formula. S equals r theta. Okay? And then you also have this area of a sector 1. Okay, so your homework, let me give that to you. Oh, way. But I'm giving you 15 minutes to get started on it. Actually, I'll write it on the back of my gear here. So we will do page 103 to 106, number 1 through 9 odd, 21, 27, 36, 37 to 40, and 43 to 49 odd.